Hello dear friends, now I came with one another topic that is called as a mechanism of size reduction, and the mechanism of size reduction plays a very important role as far as if you want to try to understand what are the size reduction equipments are there, and the size reduction equipment generally called by the terms that is known as the mills. So let's try to understand what are the mechanism of the size reduction. Before trying to understand the mechanism of the size reduction process can be achieved by the basically following two methods. The first is known as the dry grinding, and the another one is called as the wet grinding. So depending upon the fluid into which the material is in contact. As for example, in the case of dry grinding, the material is in the contact with the air, while in the case of the wet grinding, the material is in this contact with the liquid form or in the form of a slurry. The dry grinding is preferred when the moisture content of the material is less than or equal to 5%. The wet grinding we are preferring when the moisture content of the material undergoing the size reaction is greater than or equal to 50%. Dry grinding generally consume or require higher energy compared to the wet grinding, and it will produce the wider particle size distribution, while the wet grinding will going to give the narrow particle size distribution. Here there are some examples of the size reduction equipments are given, like a cutter mill, roller mill, hammer mill, ball mill, and the fluid analysis management, which is basically undergoing the dry reduction of the particles, while the colored mill, which is undergoing the wet reduction or the wet grinding of the particles. Basically, there are main four mechanisms that is undergoing for any of the size reduction equipment or the mill will be there. Let's try to understand this one by one, each of these four main mechanisms. The first one that is called as a cut. The force which is applying that is called as a cut or the cutting will be there. As shown in the diagram, the material is applied of pressure at one of the point, and the best example of this mechanism that is called the scissor. We are using the scissor, and scissor basically used for the cutting of the other paper or any of the fibrous material. But by the means of this cutting mechanism, as for example the cutter mill, we are going to get the particle size reduction in the terms of 100 to 80k micron. Another mechanism that is called as a compression. As we try to understand the simple meaning of the word compression, compression means it is the process in which we are applying the pressure or we are increasing the pressure that will be decrease the volume take place. So here as shown here the particle is there, particles is going to apply the pressure from the both sides, from the bottom and from the top, and because of that the particles is undergoing the size reduction or particle is going to broken down. The simple example of this mechanism that is the nut crackers, and the application of this and the industrial equipment that is like a roller mill, and we are using on the laboratory scale that's a piston in the mortar. Here we are going to get the particles in the size of that's a 50 to 10k micron. The third mechanism that is very important, which is known as impact. The impact means into which the particles will apply a sudden force into one particular direction. As shown in here, the particles apply the force like this one in this direction, or in this direction the particles are striking to the wall. Here the particles are going to strike by that particular surface. And the simple example, we are using the hammer. Generally, as for example, we are using the hammer in our home for fitting of that nails or something like that. We are keeping the nails, and from the back we are applying the one hard force, and by which the nail is going to be directed into the direction of a particular force. Same thing is going to happen to this one. The examples are that is the hammer mill and the disintegrator, and it will produce the particles in the range of 50 to 8000 micron. The another main mechanism that is a very important mechanism that we will call as attrition. Basically, attrition is a word which is made of the pressure and the friction. It means that when we are going for the size reduction of the particle, we are applying the pressure, and when we are applying the pressure, in this case, let's say in the downward side, and along with that, we are applying the friction force on the particles. So as a result of this, both the type of the force, okay, the particles is undergoing the size reduction. And the simple example of this equipment or this mechanism that is simple, that is we can understand by the example of that is a simple that's called a file, and the colored mill and the roller mill that's work on this particular principle, and it will give us a particle size of the 1 to 50 micron. So as we are going from the cutting to the compression to the impact towards attrition, as you can see that there is a reduction in the particle size is taking place. So as we are going from the top to the bottom, we are finding that we are going to get the more finer particle size. The another some examples into which that is we are trying to use that both the last mechanism, that's impact and attrition, together into with the equipments which work, that is like a ball mill and the fluid energy mill, that work on the both of the principle, that's impact and attrition, and it will again give the particles of the various fine set like in the range of 1 to 2000 micron. So after understanding these basic four mechanisms, let's try to understand certain terminology which are very important. The first terminology that is called as compression, another one is consolidation, and the third one is called as a compaction. So many times the students are going to confuse between these three terms. Let's try to understand the first term, compression. As the name suggests, as here the word comes, that's the pressure. So here we are finding when we are increase the pressure, there's a decrease in the volume take place. That process is called as a compression. The third process that's called consolidation. Here the word that is important, that is called as solid. So here when we are going to increase in the mechanical strength of the material due to the particle-particle interaction, as you are knowing that in the case of solid particles or in the case of the solid set, the particles are having the nearest contact with each other or the one another. So the solids material or the solid set represents the good mechanical strength. So that is called as a consolidation. The third process that is called as a compaction. So try to understand the word over here that is called a compact. As we are knowing that here, basically the compaction, it is a compression and the concentration. So I can say that like a compression plus concentration will lead to the compaction. So when we are going to apply the higher pressure, and due to which the particles are going to come near to each other, and due to which they increase the mechanical strength of the particle take place, and which is basically generally referred to the compaction. So dear friends, into this video I have highlighted the various mechanisms of the size reduction and try to explain to the three different terms, that is the compression, concentration and the compaction.